Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the strength of sigma and the pi bond. In the previous lecture we have done about this sigma and the pi bond. When the two atomic orbitals have head-on overlapping, or we can say that when the overlapped region is on the internuclear axis, then it will give rise to a sigma bond. And when two atomic orbitals overlaps sidewise, or there's lateral overlapping, or we can say the overlapped region of two atomic orbitals is perpendicular to the internuclear axis, will give rise to the pi bond. Now, the strength of sigma bond and the pi bond will depend upon the extent of overlapping, or we can say the effective region in the overlapped portion of the two atomic orbitals. The more the effective region, or we can say the more the extent of overlapping, the more strong will be the bond. Now, we also know that sigma bond and the pi bond are the covalent bonds, and covalent bonds are always formed between the non-metal and the non-metal. Now, in the group of non-metals, that's group number 15, 16 and the 17, as we move down the group, the size of atomic orbitals will increase, due to which there will be the more distance between the two nucleus, so the extent of overlapping of atomic orbitals will decrease, and hence the strength of sigma bond will decrease down the group. On the other hand, the formation of pi bond is dependent on the formation of the sigma bond. If sigma bond is weak, then pi bond will be more weaker, because the extent of sidewise overlap will decrease even more. So let's talk about it in a bit detail. I'm writing the strength of sigma and pi bond depends on the extent of overlapping of two atomic orbitals. That is, more the region of atomic orbitals in overlapped portion comma, the more stronger will be the bond. The more stronger will be the bond. Now, sigma bonds and pi bonds are the two types of covalent bond, are two types of covalent bond, and we know that what we know, that covalent bond is always formed between non-metal element and non-metal element. Now let's apply this concept on the group number 15, 16 and 17 of the periodic table. As we know, 15, 16, 17 group comprises the non-metals. is group number 15, group number 16, group number 17. Here we can also take the group number 14 also. Now the group number 14 is carbon, silicon, germanium, tin and the lead. Group number 15 is nitrogen, phosphorus, arsenic, antimony, sorry, and the bismuth. Group number 16 is oxygen, sulfur, selenium, tellurium and the polonium. Group number 17 is fluorine, chlorine, bromine, iodine and the astatine. Now let's talk about the period number. Here I am mentioning the period number. The first one is period number 2, the period number 3, period number 4, period number 5 and the period number 6. Now in the period number 2, the overlapping of 2p will take place. In period number 3, the overlapping of 3p will take place. In period number 4, 4p will be involved. In period number 5, 5p will be involved. And in period number 6, 6p will be involved. Now, as the shell number, or we can say period number, increase, the size of atomic orbitals also increase. So I am writing down the group, comma, as the shell number increase, comma, the size of atomic orbitals also increase. Also increase. Now I am writing, due to the increase in size of the atomic orbitals, there will be the greater internuclear distance between the combining atoms. I am writing, as the size of atomic orbital increase, comma, the internuclear distance, between the combining atoms also increase. Thereby what will happen? Thereby the extent, or we can say effectiveness, extent or effectiveness of overlapping of atomic orbitals, of two combining elements or atoms, decrease. So as the size of atomic orbital increase, what's going to happen? The internuclear distance between the combining atoms will increase. Thereby what will happen? The extent or effectiveness of overlapping of atomic orbital will decrease. Now, the strength of sigma bond and even the pi bond, I am writing, the strength of sigma bond is dependent, we can write is directly proportional, is directly proportional to the extent of overlapping, to the extent of overlapping of atomic orbitals. That is, more the extent of overlapping, will give rise to strong sigma bond. But here what is happening? As we are moving down the group, in case of group number 14, 15, 16, 17, as we are moving down the group, the size of atomic orbital is increasing, thereby the internuclear distance is increasing between the combining atoms, so the extent of overlapping is decreasing down the group. That's why the strength of sigma bond will decrease down the group. So here the effectiveness of overlapping of atomic orbitals down the group is decreasing, due to which what will happen, due to which, so I am writing, so as the extent of overlapping, as the extent of overlapping decrease down the group, decrease down the group, due to which strength of sigma bond will decrease down the group. Strength of sigma bond will decrease down the group, will decrease down the group. So here we can say that the elements of period number 2 and the period number 3 will form the more stronger sigma bonds as compared to the elements of period number 4, elements of period number 5 and the elements of period number 6. Now let's talk about the pi bond. We know that the formation of pi bond is dependent on the formation of sigma bond. So if down the group the strength of sigma bond will decrease, then there will be a question mark on the formation of pi bond, or we can say the pi bond will be weaker and weaker than the sigma bond. But firstly let me write one thing. As we know that sigma bond is formed by the head-on overlap of atomic orbital and pi bond is formed by side-wise overlap of atomic orbital. So the effective overlapping is more in case of sigma bond than in the case of pi bond. So first of all I am writing that strength of sigma bond is firstly much greater than the strength of pi bond. What's the reason? Here is more extent of head-on overlapping, more extent of head-on overlapping, whereas in case of pi bond I am writing less extent of lateral overlapping of two atomic orbitals which are combining. So that means the strength of sigma bond will be greater than the strength of pi bond. So down the group down the group, the strength of sigma bond is weak. Strength of sigma bond is weak. For the formation of pi bond, there must be at least one sigma bond. So if sigma bond is weak, then the strength of pi bond will be even more weaker. So I am writing, so the strength of pi bond will be even more weaker than sigma bond as we move down the group. As we move down the group. Moreover, actually, as we move down the group, the pi bond is not formed by the member which are present at the lower position of any group. So the lower member of any group will not form pi bond because of very large atomic orbitals, due to which the sidewise overlapping is not possible. So I am writing that a very important point, that only the members of period number 2 and period number 3 will form pi bonds. Due to the very large atomic orbitals of lower members of any group, comma, the extent of lateral or sidewise overlapping, the extent of lateral, or we can say sidewise overlapping, is negligible. Due to which the members of period number 4, 5, 6 and 7 will not form pi bonds. So what I have written, as we move down the group, the atomic orbitals are very large, due to which the internuclear distance is very high. So due to which we are getting a very weak sigma bond, and the extent of sidewise overlap is very negligible. Hence there will not be any sidewise overlapping in the members of period number 4, 5, 6 and 7, or we can say the lower members of any group. So they will not form pi bonds. The pi bonds are only formed by the members of period number 2 and period number 3. The pi bonds can be found between the members of period number 2 and between the element of period number 2 and the element of period number 3. Now, the pi bond is not even found between the member of period number 3 and the period number 3. I hope you got the point. That I am writing again a very important point. Pi bonds are formed between the elements of period number 2 and period number 2. Very important point. And also the pi bonds are formed between the elements of period number 2 and period number 3. But, very importantly, I am writing but, pi bonds are not formed. Pi bonds are not formed between the elements of period number 3 and period number 3. So that's all. Here what I have told, that carbon can form pi bond with carbon. Carbon can form pi bond with nitrogen. Carbon can form pi bond with oxygen. Now, phosphorus is a member of period number 3. Phosphorus can form pi bond with oxygen. Sulfur can form pi bond with oxygen. Then oxygen is a member of period number 2. But the pi bond is not formed between the elements of period number 3 itself. That is, phosphorus cannot form pi bond with phosphorus. Sulfur cannot form pi bond with sulfur. The elements or the members of the period number 3 can form pi bonds only with the members of the period number 2. And the pi bonds are not formed between the elements of period number 3 and the element of period number 3. So that's it. So as a summary of this lecture, the strength of sigma bond and pi bond will depend upon the extent of overlapping between the atomic orbitals of the combining elements. Down the group, the size of atomic orbitals increase a lot, due to which there will be the higher internuclear distance. So the extent of overlapping between the atomic orbitals will decrease down the group, and hence the strength of sigma bond will decrease down the group. On the other hand, the formation of pi bond is dependent on the formation of sigma bond. If we are getting weak sigma bond, then we will get a even more weaker pi bond, because pi bond is sidewise overlap. Or we can say, when we move down the group, the atomic orbitals, the size of atomic orbitals is very large, due to which the sidewise overlap is not possible, or we can say it's negligible, and hence the lower member of any group will not form pi bonds. The pi bonds are always formed between the members of period number 2 and the period number 2, and period number 2 and the period number 3. The pi bonds are formed between the period number 2 and the elements of period number 2. Pi bonds are formed between the elements of period number 2 and the period number 3. But pi bonds are not formed between the elements of period number 3 and the period number 3. Or we can also say the elements from period number 4 onwards. Now, elements from period number 4, 5, 6 and 7 will not form pi bonds, because atomic orbitals are very large, due to which sidewise overlap is negligible. So that's all for today. I hope you understood the topic, the strength of sigma bond and the pi bond. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button.